Many regions and their associated areas are subject to constant change. The intentional transformation of these areas into a different state or a new use involves many different planning processes. One major driver is, for example, open-cast mining, which makes many areas uninhabitable. Restoration involves renaturalization and recultivation and requires complex planning. But even urban planning brings together different processes, and so does the development of recreational parks. The transformation of an area into a recreational area requires good and extensive planning. Nowadays, nature conservation is becoming more and more important in this process, as the preservation of the environment is of particular importance. But what do all these different planning processes have in common? There is an overwhelming amount of regulations that need to be followed. These restrictions concern a lot of different issues. So, if certain animal species are present in the area, major interventions could be prohibited. Trespassing may be prohibited to protect the animals, and noise or litter may be problematic. Sometimes these regulations are permanent, sometimes they are limited in time and especially in location. So we have a lot of regulations that we have to take into account in all of these types of planning. We just need to know where they are and how to get to them so that we can assess them and comply with them. Often reports and expert opinions are prepared for this. This results in a huge amount of documents that could be relevant for planning. Sometimes important details are hidden in a few pages and they have to be found. It is important that, as far as possible, all regulations are observed to enable good planning so that execution can be carried out safely and reliably. But this is not only important for the individual project developers. Especially for nature conservation concerns, it is important for authorities and environmental associations to be able to check whether others are complying with these rules. Here in this work we have specifically focused on the topic of breeding times. In Germany, animals usually breed in known and locally well-defined areas, and for various species the breeding times are also known. Some restrictions resulting from this are also known to most people. For example, hedges must not be cut in spring and summer. Also, the pruning or even felling of trees during this time is subject to special regulations. But it is also possible that some river sections are closed to recreational activities because rare bird species breed there. Here in Leipzig, for example, the common kingfisher breeds along rivers and streams close to the shore. So if I overlook this detail in my planning and come in with excavators to redesign the shore, I do considerable damage to nature. In addition, I have to pay fines, and depending on the severity of the offense, this can result in considerable costs. Therefore, if I want to do such projects, I have to plan them carefully to make sure they fall outside of these restricted times so that my project does not cause any damage. Time and resources have to be planned well, because if certain regulations are overlooked, this can lead to significant time delays. For this reason, it is not only important to know about such restrictions, but the time aspect is particularly important. Knowing this and being able to present and interpret it is of great importance, which is why we have focused on it. Our partner in this project is the LMBV. This company is mainly responsible for the renaturation and rehabilitation of closed open-cast mines, so that landscapes like the one shown in this picture can be restored to their former state like shown here. We also received our test data set from this company. This consists of geospatial data such as polygons that are displayed on a map. Each polygon represents an area where projects have been or are being carried out. For each of these areas, there are a number of documents created specifically for the project, including expert opinions, reports on soil conditions and typical flora and fauna in the area. It is important to know what the current approach to planning new projects looks like. An important part of this is done graphically using a GIS. First, the area where the project is to take place is investigated, i.e. the geological situation is checked. Then other previous projects in the surrounding area are searched for. These projects can also be displayed on the map. And since expert opinions, once drawn up, can still be valid after the project has been completed, and restrictions recorded in them still apply. Therefore, it is necessary to check whether they overlap with the new planning area. If they do, I know immediately what I need to consider in the new project. Unfortunately, the data is not strongly linked, which means that I first have to check my planning area against other projects for overlaps, which can be quite a lot. Once that is done, and I have a set of projects that are in my area, I have to look at the associated documents for those projects. On the one hand, not all of them are digitized, so I have to search for them in the archives, and on the other hand, they sometimes consist of hundreds of pages of text that I have to read first. Even if the documents are digitized, they are only available as scanned versions. This work takes a lot of time and is very tiring because of the amount of documents. Unfortunately, this makes the work error-prone. On top of that, this work has to be repeated every time for each new project. And what happens when a task is so annoying? You try to avoid it, and it can happen that documents are not read completely, skimmed, or not read at all because people rely on their personal knowledge. In summary, the following problems arise. Past projects are not well linked, documents are not available or only in a very basic digital form. It takes many clicks to find the right projects, which makes it very time-consuming and error-prone simply because of the nature of the work. Our goal was to simplify this process and support the experts of such projects with a tool tailored to their needs. Previous matching projects must be found quickly with just a few clicks. New projects must then be planned more quickly and reliably. For this purpose, it is necessary to create appropriate relationships. Documents must be processed digitally, but also in such a way that the relevant information is directly available and there is always a reference to the source of the information. The latter is particularly important for justifying decisions, but also for explaining to outsiders exactly how planning times are calculated and why some activities are not possible. Ultimately, everything must end up in a tool that makes all this possible. To do that, we had to process the data we had. We started with the previous projects. Since these are available as geodata in the form of polygons, we intersected them all to find out which overlap with each other and thus together provide data for a corresponding area. Each document was then linked to its associated project. All relationships were then efficiently stored in a graph database for flexible access. A GIS tool was then developed that not only displays polygons and possible textual attributes, but is also designed to display exactly these relationships. In other words, it shows exactly which projects interact with each other. I will show an example of this in a moment. We presented the main work in another paper, so if you want to know more about it, you can read about it there. Another important point was the processing of the documents. So we don't just need the scanned documents, we need the exact information about their content. For that, we have to go to the sentence level and look closely at all the sentences. As an example of what can be found there, consider the following sentence. Machines heavier than 30 tons are forbidden during heavy rains. We are looking for restrictions. What am I not allowed to do, or what am I allowed to do only under certain conditions? When I have found all these sentences, I can link them to the other data and display them. As a source, I can then always specify exactly the one document from which I have this information, and I can also refer exactly to the sentence and to the corresponding page in the document. This way I can justify my planning without gaps. We have already done some basic document processing for this in another project. Here is an example of what can be done with data processed in this way. It is based on the example sentence from the previous slide. Thus, heavy vehicles are prohibited in a certain area if there is heavy rain. In the past, you first had to find this sentence, then you had to check whether it was related to the planning area, and then you had to check if the heavy rain event was present. That needed a lot of individual steps and many different data sources had to be checked manually. Now I just check a specific date in my GIS that I can select from a calendar. The tool then automatically displays all the projects, shown here in green, that are affected by a weather-related restriction on that date. Additionally, I can display weather areas, here in orange, that have been previously defined by the German Weather Service and integrated into the system. If I now select an area, the shaded area, the tool automatically shows me the associated data. At the selected time, the heavy rain event is present, and using the previously created relationships, the tool informs me that there are areas underneath that are affected by it. It does this through the red marker on the bottom right. So instead of having to check everything manually, in this case I get everything automatically delivered by the tool within a few seconds. We can build on and extend the work that has been done. For this, I'm going to briefly go through the document processing because we had to make some adjustments. We have over 32,000 documents that are several decades old and have been scanned piece by piece over the last 20 years. Of course, the scanning parameters and quality vary. We focused on reports, statements, and expert opinions because that's where the important information is. First, all documents were transformed using optical character recognition to extract the text they contained. Then a set of keywords was created to indicate various restrictions, as well as keywords indicating a specific topic, such as weather or environment. These words were used to select sentences that contained at least one of these keywords. Other randomly selected sentences were added. Then an active learning approach was used. In this approach, several annotators were presented with sentences that they had to evaluate. That is, what is the topic of the sentence and whether it is a restriction or not. These newly labeled sentences were used to train another model. The whole process was repeated for several steps until 2,000 sentences were manually labeled. However, other categories were chosen for this training, and breeding times were not included yet, especially temporal aspects were not considered in the previous work. Accordingly, an incorrectly labeled sentence is given here. It is clearly a statement about a breeding season. What we have then added are new keywords that cover exactly this topic. These are exemplary, breeding or nesting sites and seasons, nest care, and hedge trimming. So everything that somehow contains these words was selected. Thus, we were able to find those sentences specifically. In order to put this data into a temporal context, we had to extract the exact time information, since the restrictions are only valid in that time frame. Often this information was contained directly in the sentence itself. As for example, during the breeding season from March to August all work must stop. It was then sufficient to use a named entity recognition that simply looked for typical patterns, such as the two given here as examples. Sometimes, however, this information was not available in the sentence itself. For example, this sentence on the left side directly addresses the fact that the species in question is in the paragraph above. This means that the context is important and needs to be considered. Either the time period is mentioned or there is only a reference to the species. Sometimes, however, we had to look it up because it was not defined more precisely. In all these cases, we had to add the time aspect manually. Once we have this information, we can customize our graph database. A small part of it is shown here. So we have a sentence that says something about a breeding time. For this, we have a category node, and from this, we draw an edge to the document where the sentence comes from. On the edge, we write the sentence we are talking about as well as the time data. That is the start and end of the restriction. Via the category node, we can directly find all sentences that say something about breeding times and thus have all related documents. This saves us a time-consuming search and all the reading of these documents. At the same time, since we know for each document which project it belongs to, and thus which area it makes the statements about, we can also use that information. This means that if we have an area that does not have a breeding time restriction, but overlaps with an area that does, we immediately know that this restriction also applies to this other area. Let's move on to the visualization of this information. Since our project partner works mainly with maps, we also use a geographic information system for this. So I can display a section on the map. And directly, with just one click, I can display the areas with restrictions on breeding times. Our system simply asks for all the categories and gives the user the option of displaying any one of them. I no longer have to go through all the other projects and spend time trying to figure out which ones are relevant, but I can go directly to the ones that interest me and are relevant to my project. Now I can see exactly those things, I can find them very quickly. But the time aspect is still missing, so at the moment I have to go through them one by one to see when exactly they apply. To simplify this, our tool offers a timeline, as shown here. It shows a bar for several years that contains all the documents that make a statement for that years. This way I can see that there is more information for some years than for others. An overview like this is still very coarse. Therefore, I can zoom in, which refines the resolution. I can look at individual years, the quarters per year, the individual months, and I can go down to the individual day as a detailed view. To avoid simply aggregating all possible documents, I can of course filter them, for our example on breeding times. The timeline will then show me the distribution of documents that make a statement about that. But I can also filter this further by simply centering the map section on the area of interest and filtering by the region shown. This then looks like this. For the area shown near Markleberg, there are documents on this topic with a time restriction from March to September. I can now select that area in the timeline, and the tool automatically shows me all the areas or projects that are directly affected by the corresponding documents, and I also see them listed in an information panel on the right. Here I can see which restriction applies and, if necessary, I can open the document directly at the point in question and read everything in more detail. This gives me a good overview of all the restrictions and I know exactly where to find them. But I can also put them into a temporal context and evaluate them. All of this is done with just a few clicks and comparatively little effort compared to doing it manually. I can also easily check whether projects comply with these regulations, which is particularly important for environmental organizations. However, our goal was to be able to plan new projects as well, so I would like to use all of this and also only need a few clicks to get the information. For this purpose, the tool offers me the possibility to draw my new project directly onto the map. To do this, I simply create a polygon path and when I'm done, I save it and the tool automatically calculates all the necessary information, such as overlaps with other projects. Because of the efficient storage in the graph database, this is also very fast. The result is the list on the right. It shows me immediately which other projects this bicycle path would overlap with. In this case, they are a nature reserve, a residential area, and several road sections. I can also search for information relevant to me in the respective lists for the restrictions. Here, for example, I can see that the nature reserve imposes restrictions on the breeding times. Once again, I can see exactly what is relevant at a glance, have a reference to the source, and thus plan my route safely, both in terms of time and taking into account all necessary circumstances. In summary, I have presented a system that supports decision-making in urban planning, renaturalization, and redevelopment projects. Legal restrictions and other limitations were extracted from georeferenced documents and linked to their temporal facet. This eliminates the need to manually sift through large volumes of text documents in search of these restrictions. The tool allows to plan new projects while considering spatial and temporal restrictions, like bird breeding times. For this, a map is linked to a timeline visualization. Using this timeline, existing projects can be filtered and found according to the temporal component. This makes it easier to plan when and where resources are needed for specific projects. With this, our presented system can also be used to verify compliance with certain legal and nature conservation regulations. In addition, existing knowledge no longer has to rely solely on the memory of certain experts, but this knowledge has been made explicit and discoverable for all. Thank you for your attention.